if I want to start from my experience, I would say that for me also was the first experience. I didn't have this experience before. And I think maybe in the history of IIT also, this kind of labs are not still, I mean, have not been in this way implemented. So what is the mode? The mode is that students don't rely only on simulations. Students actually use hardware. And this hardware is developed in the form of a kit with all items. So this kit eventually belongs to students. So each student will receive one kit. And so therefore, to be able to handle, say, 160 students, therefore, naturally 160 kits should be prepared. So the hardware which was required and the accessories all were prepared by the Well Lab staff. And of course, some of them are assembled and prepared by the lab staff, and the main components are purchased. So therefore, what they did is, before semester starts, they actually had a very good planning. So they ordered the components in several phases, and then they started soldering and making the boards ready. So it's a Krypton board, is a programmable chip where the students can actually test many digital circuits, and it has its own IOs. So then you can imagine, considering all these students, so the residential address of all of them was checked with them. And then these kits were shipped to them by courier. And then they were asked to confirm they have received, and they were supposed not to touch them. In fact, eventually not to touch the kit till there will be a live session with them to tell them exactly what to do, and then instructions are given to them. We needed to have several, in fact, in our case, 3 head TAs. In most of the cases, we had 1 head TA for courses who manages all other TAs and schedules everything. So that's manageable. But here we had to have 3 of them, because only administration part of the lab needed 1 dedicated TA. Handling the all course lectures, online examples, online demonstrations by 1 TA. And another TA who was responsible with respect to the content and making sure that the content and training will go well. Now we needed to have groups of students, because it is not possible to have 160 students for every lab. So they were divided into 2 groups on 2 different days, so that it was manageable to train them and run experiments as if they are in the lab, but in an online mode. So therefore, we needed to have extra TAs for every session. And these extra TAs were allocated to different channels on MS Teams. So therefore, we had around 9 channels for every lab session. And 1 session was on Wednesday and 1 session was on Thursday. And every channel was managed by 1 or 2 TAs, depending on the number which is available. Now, there were different tasks which had to be planned. And then starting from day 1, after receiving the kit, it was training about what is this kit about, what kind of experiments they will do, and then the whole activity of the lab. So it was decided to have a set of extra lectures by head TAs as well as by invited faculty, so that the students will get the content better. Then these experiments all were designed in such a way that they are only manageable by the Krypton board. And then say, for example, LEDs, and then of course, a speaker, which was connected to the same board. And the students were supposed to check. Now, to check whether the kit is working or not and whether everything is in place. So we had 1 session only for that purpose. See, one thing I told you is about it's a very relatively easier to scale it up. In this mode, you can scale up for a large number of students as long as you can give them the hardware. In the offline mode, it's not very easy to scale up. In the online mode, of course, the scaling is very easy, but they don't learn anything. They don't touch the hardware. You know, there are, of course, remote hardware labs, but nothing is like actual touching and feeling the hardware. When there is a remote hardware lab, in my opinion, it's good to make remote hardware labs for demonstrations, for the actual experiments, you mean at the research level. But when it is for training, and specifically undergraduate training, and these are like second-year students, so for them, if they get exposure, second year or even third year, if they get exposure with a real hardware, that's a different experience. And specifically, we are talking about electrical engineering. So it's very important really for them to see the hardware, to see a Krypton board, to see how a CPLD IC looks like. You know, it's really different. Another point is, you see students become so, you know, interested that they are in lockdown mode, so therefore they are not here. So this gives them an opportunity to continue. So some students ask us, can I keep this board for some time and do more experiments with that? So therefore this also gives them an opportunity to have an hardware at home to work with and then run more experiments. And then, of course, at the end, we asked all of them. In fact, Mr. Mahesh from Lab, he was responsible for shipping the kits and getting them back from students. So he is now in the phase of getting the kits back from students. So the same way they shipped to them, now they ship to Lab. So it goes in other way around. Ship it back, because otherwise it becomes very expensive to give it for, because these are for free. Therefore, it is better to take them back and then give them to the next batch of students. So one thing also which was very important with respect to offline mode, in offline mode, the students have the luxury of talking to each other, going to each other's table. Here they don't have. They cannot go to each other's table. Here, time matters a lot. They cannot waste time too much because they know that they are sitting at their home. Naturally, it gives them a kind of, you know, kind of you are cautious because you know that you are alone, everything is remote, therefore you need to be focused. The focus students get is more than the focus they get in offline mode. This is the way I have it, because there they can easily talk to each other, or they are sitting next to each other and as a group, right? So say a group of 3 students. So one student is trying to work and the other 2 are talking to each other. But this doesn't happen in this mode. So I think that's why discipline also is much better in this case compared to offline mode, which is beneficial to the student also. A student knows that, okay, this time is given to me, I have to finish. By the way, it creates more stress, but when we give some freedom to students and say that, see, look, okay, we understand, explain what is your problem if you have not been able to finish even up to 6 p.m. So they explain and we see what is the problem. So we give them some deadline, but deadlines usually were, for example, till tonight 9 p.m. Finish it, upload it. So that the student also will not be so much stressed that because of that they will not be able to work and get the results. And we tried also, you know, in fact, I kept this division of the activities across various percentages till end of semester, because to see that how students perform. And depending in what areas they perform better, try to give more percentage there. And practically more than 50% of the percentage of the work was really with respect to what they were doing without stress. And overall, it worked well, means that even their grades became very well. In fact, I had given AP grade to many of them, but then I could not give, because according to rules, I had to give only to 2% of the students. But really, for those who got AP and they wanted, I really gave them just a certificate from the instructor that this student performance was really as AP level, but just because according to institute rules, we cannot go beyond 2%, therefore they got AA grade, but actually they are AP grade, equivalent with AP. And then, so this way also, because even for students also, this became a kind of, unique experience where they can talk about it somewhere else. And they told that when they had applied for, I don't know, whatever, maybe internship or something else, they had mentioned about their performance in this kind of lab. So that's why I think this also has become encouraging for them. Overall, I found this is really good. We need to think about, as I told you, methods where we can make also the offline labs more kind of individual oriented experiments rather than group oriented experiments. See, one thing I should emphasize, what I mean individual mode compared to group mode, this is for the experiments which are at the, say, UG level, and they are not really projects. Though even we had a small project for the lab, which was the last experiments, that music box eventually. This you can consider it as a project, but still it was performed in individual mode. So therefore, as long as the experiments are not going beyond the capability of a single student, I think there is no need really to group experiments. This is what I want just to emphasize. However, if there are labs where the whole lab is defined based on only projects, then yes, still the group work is required. Mode of conduct, yes, this was with respect to space. For example, and that I told you, like they don't need really to be in the lab, because if there is no group and they don't need any instrument to use, and they can only rely on a portable setup, which is given to them as a one single setup. Even see, they had to have their laptop, of course. So they have their laptop and they have their disk key. So 2 items. It is good enough. So therefore, they can sit in lecture hall and run the experiment individually. And all TAs who were in the channels, now they can be in the lecture hall. So it will work very well. It's like a practical class. And this is, in fact, undergraduate labs or practical classes. They should be considered that way, so that the students will learn theory, will also implement. I think one thing is like example of machines lab I told you. See, this is subject to possibility of giving the students that hardware or that platform they need to work. Even it could be more than one. I give you example. This is about projects, but for example, I have students, or I had students last year during lockdown who actually they carried several items with themselves. Even for one case, we actually shipped items to him. So, but this was of course a project. It was not a lab, but it was a project. And then he worked at home. So therefore, as long as the components and modules are not so bulky and heavy, they can be shipped by courier, and also the shipping cost is not so expensive. I think this model can be easily used for any other lab in any other domain. As long as this is possible, it will work. It will work very well. And also, even in one case, I had a student who had to do more experiments with instruments also. So I took permission, and then he actually carried the instrument home. And then he allocated a small part of their home and make a small kind of lab with the instruments. So I took permission for 2 months. And then he conducted the experiments he was supposed to conduct in IT at home. And then after 2 months, he returned everything. Of course, he was staying in Bombay. That was easier because he was able to carry and return. So there was no courier. But even if required, so it can be courier, because there are also instruments which are not very bulky. So they are small. So they can be even considered as a part of the package. And students also learn how to really work in this mode, in the sense that they give them also a sense of responsibility. A kit is given to me, or a set of instruments or small devices are given to me for free. So I need to be super careful and do everything and then return it again in the same, we asked them again to return it with the same way. So eventually Mahesh told them that, see, the same way it is packed, you pack it again and then send it back. So I think it's good. It's a kind of life lesson, because undergraduate students want to learn many things. And this is one of the things they learn. How to really, work in a completely, be flexible to still do the same thing you were supposed to do in a different place when you are not able to go to that place, but still you do the work. So I think this also gave a lot of extra technical, I would call it extra curriculum kind of learning about all aspects. For example, some of them, because the second wave started, therefore they could not ship it. So courier stopped. So therefore we had to tell them no problem. So you wait, and then you have time, of course, kit with you, you can run more experiments, but then after that you return. One thing I want to say is that beyond this, there are many startups before COVID had started, making educational kits, right? And then saying that these educational kits can operate even remotely. Therefore, universities can acquire them, and then the students can work with these kits remotely. So I remember at least one of my graduated MTech students was joined in a startup for some time to actually help them in this activity. He was very interested. But when I see that actually at that time, this was something which could have been used well. I mean, it was, but in a different mode. The mode was, at that time, they were selling these kits to the institutes and they were putting them in their labs. And then the students were remotely working with these kits, which was good. So we can go one step further. So startups who can actually make these kits, ship them to the students, take them from students, they become eventually the people who take care of logistics, because logistics takes a lot of time.
So I'm Professor Saravanan Vijayakumaran, and my colleague is Professor Rajbabu Velmurulab. We both were instructors for E337 Microprocessors Lab, which ran in the spring of 2021. So it was run in a hybrid mode, where the microprocessor lab involves a microprocessor kit, which is called the PT51 board, which is built around this 8051 microprocessor or a microcontroller. So we shipped the boards to the students. So this year, because of the pandemic, there were 2 sections of the course running. So about 150 third year students in one section and 160 second year students in the other section. So a total of about 312 students were registered for the course. So we shipped about more than 300 boards to the students, and the students had to do these experiments, which we were releasing every week at home. And so we had 7 experiments which they had to do. And during the lab slot, the TAs would take a viva of the students. So they would have students would have to upload their codes in Moodle before the lab slot began. And then during the lab slot, we had a team of more than 20 TAs who would take a viva of each student individually. Then apart from this 7 lab experiments, we also had some Moodle assignments where we had some automatically auto-graded multiple choice and sometimes fill in the blank Moodle questions, which the students had to answer. And these Moodle questions were based on the material which was being covered in that week's lab experiment. So for the Moodle, to avoid students copying each other's answers, so we used a Moodle question format. So there is an option to generate, programmatically generate Moodle questions along with answers, which can be uploaded into Moodle. And this creates a question bank, and then we can assign a random question to the student. So every week we would generate about 150 random questions, and a random question would be assigned to students. So each Moodle assignment had about 3 questions. So about 450 questions, and one each from each of the 150 groups was assigned. So in this, we got a lot of help from the TAs. So the Wadhwani Electronics Lab also has these MTech 3-year MTech RAs. So they also helped in preparing these questions, and we collaborated in creating these questions over GitHub. So we had a private repository where we would instructors, me and Rajbabu, would request the RAs to come up with some question ideas, and then we would edit it and make some maybe grammatical corrections here and there, and then do a check. Then we also, just to make sure, because this is like we are deploying these questions, and if there are errors in the questions, then we'll have to do a lot more work. So we would upload these questions in another dummy Moodle course, and I would request some of the RAs, the MTech RAs in Well Lab, to do a review. So they would review these questions and make sure that there is no errors, and then we would release it to the students. Maybe there was only one instance in the 6 Moodle assignments we had. Maybe there was only one instance where a question was wrong, and we had to give credit to everybody, even if they did not attempt it. And so we had the weekly assignments, we had the Moodle, and then finally we had a project which was about 20% of the grade. The project had to be done individually. So because we would, again, to prevent cheating to some extent, we came up with 15 project ideas. Each project description was about 1 or 2 pages of PDF with a description, like a specification of what the project is supposed to do. For example, one project was like a very simple form of Tetris. So microcontroller board has a small LED screen. So you would have these obstacles coming, and you had to move your cursor to avoid them. So that was one of the projects. And the project was auto fare calculator. So we had these, so microcontroller board, it has some button switches which you can specify, you can use to give input. So we said that each of those buttons gives you a speed for the auto, and you have to calculate the fare of the auto rickshaw at the end of the trip. So projects like these, we had 15 such projects. Again, we got ideas from the TAs and the RAs, and then we edited those using GitHub. We iteratively arrived at the problem descriptions, and then we assigned those 15 projects to students somewhat randomly. It was actually cyclical. So we had a list of students, and we'd give the first 15 students the 15 projects. Next 15 would get those 15, and so on. So there was some overlap, but we could not come up with 150 or 300 different project descriptions. So we just went with the middle path of having some variety. And these projects were again, before the end sems, about 3 or 4 weeks before the end sems, the regular lab weekly experiments stopped, and then the students had time to work on their project. And then we had a half-an-hour viva at the end, where the video viva, where the student was supposed to explain his code and explain how the project was. So these were the 3 components: weekly assignments, then Moodle, auto-graded Moodle assignments, and the project. So we do not have any exams, mainly because conducting an exam using a hardware kit where something might go wrong at any moment, that was something we did not want to deal with. So we had only these for the evaluation. Rajbabu, you want to add something?
No, I think, yeah, so that way the course content was almost similar to what we used to do in a regular semester. Only thing we consciously did is, I think this may also help, is when we kind of re-looked at these experiments, we made sure that these experiments were not exhaustive to do everything, but really like a step-by-step kind of thing, which, I mean, it's really helped, because in this case, like for me, I've been looking at this lab for some time, and Sarva had just started looking at this lab. So we kind of, I think that was one of the key aspects from the lab and the student perspective, because they were not like overloaded with this lab experiment that they have to complete in a week. But I think we gave enough step-by-step things so they can take it in a very, I would say, in a more relaxed way and complete what was asked to complete. So that I think was a big thing, because otherwise in the regular lab, we used to overflow to the next lab. And this was a thing usually we try to avoid in the earlier labs. So this online forced us to relook at what we want to offer. And I think that, I think that's certainly something which going forward, this lab will benefit from. So, so that way that module 7 labs we said were mostly completed in that week, with very less assistance or help from the RS before. Weak students were helped, but some of the good students, just by reading the manual and what was made available to them, were able to do the lab. So that way, that's one about the handout and the reports which were asked to be done. The other thing also, the hardware experiment, we limited it so that we don't have all the equipments to test and verify, no debugging capacity. So that was a kind of handicap, but that is how, that's one other thing. If I want to just outlay the course, this is the thing which we did in the course. So apart from that, I think that's what I would say, that's a kind of a good view of what the course did and how we were able to conduct this online course. I think that was, I think, maybe the outline of the course. But just to answer, I think one question was, what did we feel as professors in doing this course? I think one thing from my view is, at least we felt good that we didn't have to postpone this lab once more, because this lab is kind of important lab along with the course, in that it motivates some of the students, maybe not all, but certainly few students who get motivated to do either further studies or further research along this line. So that way, having the lab in kind of somewhat similar time, I think we did what we could, and that way we didn't lose on that part. If we had delayed, we could have, but if we had delayed, it may not have helped the student too much, at least those who wanted to do research in this area. That is what, so that basically we felt that this was that we did a good thing. Of course, we had to look back and see what went wrong really. We don't see anything now, but that was the thing I wanted to add.
Running this lab in a hybrid model would not have been possible without the initiative and the help of the Wadhwani Electronics Lab staff and the MTech RAs. So we take 3-year MTech students every year in this Wadhwani Electronics Lab, and they went above and beyond their usual responsibilities to make sure that this lab ran in a smooth manner. For example, in this lab, the students are supposed to install a driver on their machines, which will help their laptops communicate with the microcontroller board. Sometimes this would not work for students, maybe because they missed a step in the instructions, or maybe because of some quirk of their operating system. So the RAs would actually have a video call with the student, ask them to share their screen and debug all these driver issues. So we had some RAs whose main job, apart from the usual duties of taking Viva of the students, was to help students debug their setup. So, and we also, during the lab, we had already given clear instructions that plagiarism will not be tolerated. But checking for plagiarism is not a mean feat. It's a very difficult task. So some RAs actually use some tools from the internet to check all these programs which are submitted by the students, to check for similarities, and they gave the feedback to the students, and we penalize students accordingly, so that later they learned that this is not acceptable behavior. But again, because of the numbers were so large, and sometimes these checks have to be done manually, it was a lot of effort. So 150 students in a batch. So between the batches, we had slightly different experiments. So we did not notice any plagiarism across batches, but within a batch, there were some instances, and after the initial feedback, those cases fell down to a very negligible number. So I would say the main ingredient for the success of a hybrid mode lab is the supporting staff. As instructors, we can only do so much, but there is a lot of other work which needs to be done to help the students. And so if we don't have support staff, then we would have to do that. So because the support staff was so efficient and was so proactive in providing that support, there was much less load on us in spite of there being 2 sections of the lab being run in the same system.
Though there were 2 labs, we thought it would have been much more effort from our part, but because the RAs and TAs stepped in and many things were done, it was still effort from our side because there were small changes we had to make between the 2 labs, and that was there. But then even if we make, this would not have been executed if we didn't have any RAs and TAs to take it forward, right? Because so essentially execution needed a good, I think I've already said, it's a good amount of support staff and their effort. I mean, significant effort from some of them, and at least more than the minimum effort for everyone who was part of this thing, because being there twice, interacting over a video. So we have accident. I mean, occasionally we also get into this, like to just say, did they, as instructors, how much did we interact with the students? That part may be minimal, but which means that they were equally supported by these RAs and TAs. And when we do get interaction with the TAs, we could find the difficulty in doing such a thing, right? I mean, you're asking questions, you're asking the student to share the screen, and then you have to make also the student, and this is where some of the RAs were more, I mean, doing extra effort in saying they made the student comfortable in making that, though they're not here physically, they tried to help them as much as they can, which I am sure that many of the students miss that part, because that is the difference between a physical lab and this online lab. They can't kind of instantly ask doubts and keep working with the RA beside them, which wasn't there. But I think some students did make use of these RAs in terms of how to do their lab, and so that way, I think that was, some difficulties were handled well by the RAs, if not all, but certainly there are few who handled it much better. And those students, I think, would have benefited much more. So what we feel, at least that's what I felt, is certainly good students, I think, benefited well, in the sense, not necessarily from the RA, but the whole setup. Weaker student might have felt a little difficulty at times. Some of them tried to overcome by interacting with us or with the TAs more often and went through it. And some, I think, probably didn't make that effort, and we can understand that that's the difference between a physical lab and kind of online lab. This is despite some RAs specifically trying to call them, interact with them and help them. But I think we cannot do beyond some level. So that's the only, in terms of interaction with the students, how did it differ? This was one of the things. Same problem happens in a physical lab also, but here again, similar thing continued.
In the offline lab, there is a 3-hour slot, and the students are given some pre-lab assignment which is to motivate them to get used to the instructions which they'll be using to do the lab in the slot. And they come in, and the Wadhwani Electronics Lab, the space is not very large, so all of them cannot fit in one 3-hour slot. So there's multiple 3-hour slots over the week. So a subset of them comes in, and they are divided into groups of 3, and 3 of them share one microcontroller kit. 2 groups of 2. So groups of 2, and they share one microcontroller, that board, that PT51 board, and they are supposed to finish that experiment in that slot itself, in that 3-hour slot. But there are these TAs and RAs who are around, and if they get stuck or if they have some doubts, they can immediately ask those TAs, RAs for help. But in the offline, the difference is that we gave them, so we would release the experiment or the lab sheet about maybe 4 or 5 days before the deadline. So we had labs on Mondays and Wednesdays. So the lab sheet for which is due on Monday would be released around maybe Thursday, and they have to finish it by Monday. And Monday from 2 to 5 in the lab slot, only the Viva would happen. So now if a student is trying to attempt this lab on his own, first of all, there is no group. So the student is supposed to do it alone. And we allowed discussion, but we said everybody should write down their own solutions, submit their own solutions. So maybe some of them were discussing amongst themselves, but the RAs and TAs are not like just standing nearby to just wave and get their attention, and you just speak to them immediately. So that immediate connection is not there. The instantaneous connection is not there. So the one that is what Professor Rajbabu was saying earlier, that for the weaker students, getting help would have been harder. But at the same time, the weaker students now have to work on their own. There is no partner who can help. So that way, maybe the lab demanded more from the students. Students who are doing well, they were anyway able to do it, but the other students probably struggled a little bit. And if they were proactive in getting help from the TAs, they got that. But some of them also have, they are reluctant to ask, and they were struggling to complete the labs. Going forward, space in the well lab is an issue. So as the class sizes become larger, as the batch sizes become larger, fitting them all into the weekly slots where that space in Wadhwani Electronics Lab is shared by multiple other courses, that will become more and more difficult. So we might explore doing this kind of issuing kits to the students and asking them to try the experiments in their hostel. And maybe we may still have some slots where the lab itself has a lot of other equipment like oscilloscopes and function generators. So we had to restrict the lab sheets in this hybrid mode to experiments which did not involve any of that other. So in the offline lab, we had more freedom to come up with experiments. Maybe Rajbabu can add some more.
Yeah, so just minor correction. I think this can be edited later. So the projects you are done in group, but the experiment they were doing in kits. So, but the group thing still happened because they were coming as a batch, and there are four students in a table. So that way there was kind of a pseudo group, and people would help. So that, I think that is the part which was completely missed. So that's why individual effort really mattered more here. So that, I think that's one minor note. The other thing, I think I've covered most of it.
So you're saying that when they come in the offline lab, they are all given individual kits?
Yeah,
to
each of them had a kit. Yeah, they were given individual kits. It's just that on the desk there were 4 people, so the RAs were around them, and they discuss very kind of quite openly, though they come with some prior preparation, which wasn't here at all. That's why that group thing really was important and didn't happen. And yes, equipments, I think Sarva pointed already all the key points. The other thing is, so this was what, like, I think this is to kind of indicate the difference between this fully offline and this hybrid mode. While we succeeded in giving them a feel for the hardware, which will not be there in a completely simulation environment, what we couldn't give was this actually using these equipments, which is a good skill which you can only pick up in labs. Like, what are the knobs in this oscilloscope, where the function generator is, how do you connect the circuit to take input from this function generator, send it to the microcontroller. We gave some minimal components to the students so that they are safe enough that they don't get damaged, but we couldn't give all the possible equipment. So that was the one which probably is the missing element compared to an offline lab. And because of this missing equipments and other thing, when the student, of course, there were not too heavy hardware dependent experiment, but even for some simple hardware experiment, it was like a black box. They couldn't debug really. If a circuit, there was some minimal connection they had to make. And if that didn't work, we had to settle and say, okay, this speaker doesn't work, or this chip is damaged. And so that's what was able to be done in this hybrid mode, which would not have happened in the offline mode. That's the, I mean, otherwise, I think all the aspects of a difference between offline and online and a hybrid mode, I think, is covered.
Yeah. So the advantage of the offline mode, like what Professor Rajbabu was saying, is that you have all these other equipment like oscilloscopes and function generators, and we can come up with a more complicated setups for the lab experiments. Complicated in the sense that you can take inputs from the function generator, maybe debug using the oscilloscopes and things like that. But given the class sizes are increasing, we may be forced to explore more restricted setups, because issuing the kits to the students, one advantage is that they have more time to learn how to do things at their own pace. So suppose I release the lab sheet on Thursday and it's due on Monday, then maybe the student can try it out and see how hard it is, and he realizes it is hard, he or she realizes it is hard, then they decide that, okay, I should spend more time on the weekend, learn about this. Maybe I'm not fully comfortable with what was taught in the class. I need to spend more time. But when you have this lab slot, then they are supposed to finish in that lab slot. If they can't, then it rolls over to the next lab. And sometimes we have some makeup slots where I think maybe Rajbabu can correct me. At the end of the regular lab sequence, then the students who were not able to complete their experiments in their regular sequence, they would come and they would finish these lab experiments. I think so that that would be
there are these additional slots.
To repeat what I said, so the microcontroller lab, it involves some programming. So you're given an experiment and you're supposed to do some programming to achieve some task. So not everybody is comfortable with programming, and especially E students, they probably take only one programming course before they encounter the microcontroller lab. Now that lab will run in the 4th semester, so it'll be quite early in their BTech career. So people take time to warm up to programming, and sometimes they have some hangups that this thing programming is hard, or depending on their performance in their CS 101 kind of course. So this in the offline lab, we have this, it's almost like a 3-hour slot, and given that they may be taking courses after the slot, they are restricted by that time there that they're spending in the lab to finish that experiment. So they may be in a hurry, they may not have enough time to digest the material and do it at their own pace. In the hybrid mode, if we issue the kits to the student, they may not have access to all the function generator and all those other equipment, but at least the programming part, which involves only the microcontroller and the laptop, they can do that at a much slower pace and learn at their own pace, I would say. So maybe that trade-off is there, that offline lab, more equipment available, but hybrid mode, you have one thing is that there's no space constraint. So we don't need to cram everybody in different slots in the Wadhwani Electronics Lab. But you also get this added benefit that students learn programming at their own pace, and they can try to do their experiments, and they may be less tempted to cheat, in the sense that if there's too much of a hurry, then there may be a temptation to just ask a friend that, okay, how does this work or something. But they may be more open to trying things on their own. So I think those trade-offs are there, which people, if they're other faculty are considering the hybrid mode, they can consider these trade-offs also. Yeah, go ahead.
So I just had written something. I'll say that. So when others want to consider, the thing which one of the thing probably is the cost of the kit. Of course, this I think you can get more input from the Well Lab, the actual thing which was shipped. But certainly that was one of the things. So if we think of conducting, okay, we'll send a kit to everyone and do the experiment. In our case, we were like, I think really because of this hard work put in by the Well Lab and the people in Well Lab, we were able to get a very reasonably low cost kit because it was made in-house, and they figured out a mechanism to make it in large scale before even we were thinking about these labs. So that way, I think the Well Lab really played a big part. And because of that, the cost was not a big factor when we consider. It was certainly costly maybe than an offline lab, but it wasn't very costly. So that is, I think, something which has to be considered if someone wants to do this hybrid mode, because kit is something you have to consider. And then if you still go it, then you have to relook at the experiments. You just go with the same set of experiments which you had in your offline mode, right? So you have to limit the kind of scope of this experiment, and then see if these experiments are feasible, and then I think they could go. So this is more from that, I would say, the technical aspect of if such hybrid modes of lab, sending the kits, how scalable is it? That's a technical part of it, but yeah, Sarva, you can add now.
Yes, so maybe for faculty who are thinking about conducting these labs in hybrid mode, one of the activity which took up a lot of energy from the instructors was that when plagiarism cases were detected, then the students who did the work, but they shared it with their peers, we had a policy of punishing everyone equally. So we said that it doesn't matter if you share the code or you're the one who is copying the code, the penalties are equal, just so that the people who are sharing code have some skin in the game, in the sense that if people who wrote the code are not punished, then they may just do it freely, and it'll be it's malpractice. So one thing is that because maybe some of the students are early in their BTech, they don't understand what is acceptable and what is unacceptable. So it might help to be explicit about what kind of situations are punishable. Because we have had many email threads with students where they are stating their case of how they wrote the code and they shared it with their friend, and their friend promised that they would not like copy the code as it is. They will just use it to get an idea of how to do the solution, and they will write up their own solution. But in the end, this friend just submits the exact same code, and then it is caught by our TAs who are checking for plagiarism. And sometimes we feel for the students also, because it seems that they are being genuine. But once we came up with the policy and we announced it right at the beginning of the course, we had no choice but to apply the policy uniformly, in the sense that with no exceptions, we just said that if the codes are identical and we have if we have evidence that some plagiarism has happened, so we are going to punish all the parties involved in the same amount, which is basically getting 0 in that particular lab assignment. So maybe some more sensitization in the beginning of the course. We had a presentation right in the beginning where we explicitly stated that plagiarism is not allowed, and even if you write the code, but if you share it, you will get the same punishment. But still, somehow students don't seem to wrap their heads around it. Maybe because of this online mode of instruction where they're not around their peers, they don't interact much and don't know what the culture is. So a lot of students said that they were surprised that the assignments should be checked so carefully. So maybe some sensitization right at the beginning about how the plagiarism cases will be dealt with more explicit examples that can, I think, help. Because we also don't like dealing with students and then being like the gatekeepers, as if we don't gain anything by cutting those marks, but we are just applying the course policy uniformly. So it took a lot of emotional energy, I would say, just writing those emails and reading those complaints. And students sometimes lost a lot of marks, and then they would quite upset about it. Some cases, some students were affected by COVID, and they felt that their friend is asking for their help, and at this time everybody is struggling, so they felt that okay, it's a good thing to help them, so they ended up sharing the code. And so sometimes we felt for those students, but just because we cannot make an exception, so we had to deal with them the same way as we dealt with the other cases. So maybe some more sensitization at the beginning of the course about how plagiarism cases will be dealt with, that might help.
This is our setup for experiment 6. For convenience, I have used the speaker in high volume mode. Switch 8 represents the reset signal. When I turn off switch 8, we can hear the music. Now I will turn off switch 8. We see that the LED as well as the speaker turns off.